Voices hum like whispers in the deep dark night.
Welcome to the AI Riff, where we cut through the noise and break down the top AI stories of the week with real talk and real relevance. No hype, no fluff, just a vendor-agnostic take on what's actually shaping your world today. Whether you're in tech, lending, or just trying to make sense of the headlines, we're here to separate the wheat from the chaff and the facts from the fiction. Now let's get this started with your hosts, Mario Diabenedetto, Rob Katz, and me, Kyle Myers. We hope you enjoy this episode of the AI Riff.
It's a double dozen.
Double, oh, 24. Okay, gotcha. 2-4, got it. Yep. Okay.
I can't wait till we get to episode 67 and our kids all go crazy because it's 6-7.
Yeah, it's 6. Well, we could just say that the next episode is 6-7, and we'd get a lot of people viewing. What?
Oh, that would really mess people up.
Yep.
Yeah. Well, you're right, because they're counting each one. Oh, wait, I missed one, and they'll be looking for it. Yeah.
It's really how I track the month is by the episode that we're on.
No wonder you're still in October. What do we got today, Mario?
Today we're talking moonshot.
Moonshine?
Not like drinking. Like
Like okay.
Google moonshot.
Mm-hmm.
Google's moonshot to try to leverage AI in space. Not necessarily on the moon, in space. So
Okay.
there's all kinds of benefits to being able to basically run, I'll say, data centers in space.
It's colder.
That's what it absolutely is colder. And that's what they're trying to do. They said they're going to have a couple of satellites launched by 2027, which isn't that far away.
Well, for clarity, the two satellites that they're planning on launching in 2027 are for testing purposes. I don't think they're launching data center things in 2027. That's correct. But yeah.
Thanks for grounding us, Rob.
You got it, baby.
And so that's as compared to there's a couple companies in China who have launched satellites that they say are the beginning of a 2,800 satellite mesh they want to create for that same effect.
How many does X have up there right now?
So Elon says he's going to use his existing Starlink satellites to do this. Those little buggers you see in the sky.
How does
I don't know.
How's he going to put the new? What is he going to have? Little people go up there like a space launch and walk on them? And
so one of the big challenges with stuff in space is latency, and so I'm totally imagining that one of the things he gets the advantage of is he has those Starlink satellites to do a lot of the communications backbone, right? So imagine he's already got the network to communicate amongst things, and so he can really have the other satellites be pure compute. There's this whole thing you have to get your head around. Like, I think we think data center is like constant inflow of data, constant output of data. Well, that doesn't work in space, right? You can't, you don't have the bandwidth to do that. And there's whole things about low Earth orbits, high Earth orbits, and yada yada. Like it's really complex, but it's a different model. It's more like a AI training type of thing where it's like, I'm going to just ship a bunch of data to you, and you are going to process it for periods of time where you're not, always consuming, high quantities of data that are out there. But the premise, I think, is that if somebody can master this, it's ridiculous pricing, right? It's ridiculous capability for the lack of energy you need because you don't have all the Earth's, problems, and you do have the cold, as you said.
Yeah.
You get cheap compute.
I think let's break this down a little bit, bringing it back to Earth, Kyle, as you said. For those three people that watched our last episode and listened to our last episode, we actually kind of went off at the end of it that we talked about power, and Microsoft's investing or bought 3 Mile Island as a source for power for data center growth and powering data centers. Lots of stuff in Greenland because they've got cheaper power there and everything like that. So is moving stuff to space something that makes sense. So I've been in plenty of data centers over my career. I'm sure you guys have as well. And the reality of it is yeah, a big part of the data center is the power plant and the backup batteries and the diesel generators, and all that would go away because it would all be solar. But you still have racks and racks and racks of servers and switches and network equipment and all that other stuff. And I don't know a single data center that doesn't have hands-on support for when something goes wrong.
Who's doing that?
Yeah.
Is that a new job?
I want to go to
That's an
space.
AI created job.
There you go. There you go.
Yeah.
So there's some pretty big logistical challenges that are going to have to be overcome to do this. On the positive side, the fact that it's freezing cold, the fact that there's unlimited solar, there's no clouds getting in the way between, you know, the solar collectors and the sun to bring in the power that needs to be there. There's no dust. There's no gravity. So does that help in any way? That's, I think, some of these test satellites that are going to be going up in the next year are investigating that. It's audacious. Like, this is a huge, I mean, they call it moonshot, right? It's a big, audacious goal. I think it's fascinating. And watching this over the next couple of years is going to be really interesting to see what directions things go in. Possibly totally unrelated. And I'm sorry I don't have a reference article for this, but I think I saw last week or the week before that some Chinese satellite shined a green laser against some, maybe it was one of X's or Starlink satellites. And so maybe that's for that data transfer. It could have been nefarious. It could have been in a bad way. Like, let's just test if we could shoot these things out of space. Or could it be, oh, are we going to be able to transmit data over laser in, you know, at the speed of light, satellite to satellite? So I'm hoping it's for the better. Could be totally unrelated. It could be a made up story for all I know. So sorry.
It could have been someone trying to get their cat's attention. You know,
yeah,
who knows?
That's true.
You know?
So what's partially to me interesting about this is that first of all, you don't hear a lot about it. So I saw a whole separate thing quite a while ago where Eric Schmidt, one of the Google founders, bought a rocket company because he wanted to do this. And fundamentally, if you can't get stuff out there, if you have to pay somebody else to get satellites up, it's, you know, the economics already become challenging. But the other part of this equation is you hear all of this money going into data centers, right? All the data center build out and the tens of billions of dollars, right? Hundreds of billions of dollars at this point that people are spending, but you don't hear about the spend over here. And I can imagine that this spend would add up really fast, at least at the beginning, right? That it's, somebody has to be paying that bill.
So the article that talks about moonshot estimates over the next 3 years on data center spend alone, $3 trillion.
No.
That's what they're saying. And then Google has outlined $93 billion in 2025 in data center infrastructure, just data centers.
Yeah.
So yeah, so it's $3 trillion. Say if you're going to spend a couple billion, 100 billion getting, you know, satellites launched out of $3 trillion. I mean, that's a huge number.
So you brought up a good point earlier, Rob. How are you going to get? It's supposed to efficiently churn through data that's stored where? Like, we assume, okay, let's just take a normal. So we're not talking about terabytes of data. We're talking about, what is it?
Petabytes.
What's that?
Petabytes.
Petabytes. I don't know how big the server right now that has to have petabytes on it. Is it a laptop? Could it have a petabyte on it? I mean, how big does the server have to be to have the storage capabilities? And are we just ahead of the curve, meaning the storage is getting smaller and smaller and smaller? Are we going to have to get that even smaller to get it on a satellite to be useful in space in a data center that's in space? And then actually, how big is this satellite going to be? Like, is it going to be the size of a, you know, laundry basket, or is it going to be the size of a, you know, a stadium, a football stadium?
International Space Station, you know, something like that, right?
Yeah. Do you have to build it? Is it component? Like, do you have to put up a bunch of rockets and then keep attaching things onto it like Transformers, you know, and you Just make it all like a big, huge state. Is that I mean, I guess it all could be true, right? We are going to get smaller. It's always been getting smaller and smaller, the size of drives that can, in physical size, to house more data. And then I'm just the concept is blowing my mind. But how does that help other than there's the answer. Other than the energy, that's it. Energy, water, the do you need a fan in space? I don't think you do, right? Because there's no air. So what would a fan do?
So
But
I actually think you do need mechanisms to insulate the entire mechanism, the entire enclosure. So, and there is a deep dive that we can share maybe along with when we post about this that goes into all that because it's super super complex to pull this off. So
Yeah.
I'll just throw out one little factoid. Starlink, so Elon Musk's satellites that effectively have good response time, right? They're potentially capable of doing a 50 millisecond round trip, which is apparently comparable to what you can get on the ground. They're 550 kilometers. So what's that? 300 some miles in orbit. It's considered a very low Earth orbit.
yeah,
Something in that low Earth orbit won't stay there forever. So they say maybe a decade, maybe 15 years. So you have a time where these things basically are going to fall back to Earth, right? So that's low Earth orbit. So you got to these things become disposable. So you not only have to put them up there, right? They have to be economical to put up there. So
right.
all
They have
these
to last 10 years, get
convergence,
their economic life within 10 years, and then
right?
they're
You have to have
done.
this convergence of the rockets have to be economical. They have to be economical. Getting the data to from them has to be economical. That's I guess
The laser you use to shoot them down has to be economical.
that's why it's a moonshot, right? Back to what Rob said, right? If it was easy, they'd just be doing it. But it's super crazy complex, and to me it sounds like the type of thing that's going to take 20 to 40 years.
So wait a second.
To figure out.
So are you saying we might actually get to Mars before we put a data center in space?
Ooh, that's a good question.
That would, that
A
just seems like
data center for test purposes. People will have a data center.
That's 2027, right? So we're, I'm sitting here going, okay, the complexities of going to Mars are way more. I think way more than that. Maybe they're not. Maybe it's easier to just do a single shot flight than to account for all the math that you have to keep a data center. And then what happens when that data center loses orbit with all your data on it? That's like dropping your laptop with all your photos. It's like, damn it.
So I think they have to have a whole redundant architecture, right? Where no single point of failure, which again just messes with the economics.
By the way, it's a whole new definition of cloud computing.
But there are no clouds. It's above the cloud computing. Above the cloud. We could coin that now. That's not cloud. It's above the cloud. Yeah. But that's interesting stuff. So there's no role of AI in this though, right? It's just the fact that this is the hardware needed to run AI.
Oh,
right?
Yeah. So we've talked on prior episodes that the infrastructure, if I'm an investor, I like to invest in things that I think have a return. The infrastructure to support the AI growth, it's the shovels for the gold rush, right? It is, that's where money's being, look, we just said they're going to spend $3 trillion over 3 years on data center expansion. So, is it AI? No, it's the skeleton that makes AI work. And yes, of course, they'll use AI to help them figure out how to solve all the problems. And of course, it'll be 15% of what AI kicks out will be wrong. And hopefully it'll be the 15% that the humans catch. So,
yeah.
So on that note, I want to share a little bit about some AI experience that I had in November. I spent most of November in New Zealand, as you guys know. And if you've ever been to New Zealand, it is, parts of it are like the Alps, which I wasn't expecting, but lots of rolling hills, green grass, and everybody's a farmer and they farm sheep. They have millions and millions and millions of sheep. And so they got all these paddocks with these green grass. They put the sheep on them and they rotate the sheep around the different paddocks so the grass stays healthiest and the sheep can grow the best and all that other stuff. Mm-hmm. So it's amazing how these farmers, they have no big industrial growth, right? So all these family farmers with these, 10,000 sheep or 1,000 sheep or whatever it is with their paddocks and stuff, how they're using AI to decide which sheep go on which paddock, it's a total joke. I'm kidding. They don't use AI at all. They've been doing it the same way for hundreds of years. Yeah, I had 3 weeks in New Zealand. I had 3 weeks of not using AI. It was awesome.
People who are not watching
me,
missed
Rob.
Kyle's
You got
face, because Kyle's face was worth watching this whole thing.
I was like,
doing the Spotify audio.
I was like, please go on. Tell me how it did it.
Rob, you should have just said that. And they're taking the sheep and they're going to have them wear helmets and they're going to go into space so they can have sheep farms in space.
Keep it up, Mario.
And they're gonna watch the data centers up there.
Yeah, that's right. They're going to wrap them in wool to keep them warm.
Yeah. Well, they will be warm in space because they do have all that wool. So
That's right.
That's a good story. Mario, anything you use technology for or didn't use technology for?
So because we're on the theme of moonshot.
AI for.
Yeah, just because we're on the theme of moonshot, I did use anti-gravity, which is the new coding tool from Google.
Okay.
And I did not do a lot, but I did challenge it. I had a problem that Lovable was challenged to solve, and it had consistently not solved it. I kind of put it off to the side, and I fed it into anti-gravity, and it got it, figured it out. So the weird part was when I went back and had it do a slight modification, it basically redid the entire problem and came out with something completely. So it was writing code. So if you imagine I said, write this, and it did it. It did perfect. It worked. And then I said, okay, just make this one tweak. It rewrote all the code. And so it was a totally different code base. Like it looked totally different. Effectively got to the same end, but it was totally different. Wow. So
that's one of the biggest frustrations of vibe coding is when the agents do that.
Yeah. I think that is one of the things I saw that they're working to constrain with Cursor, right? With Anthropic, is to give it don't mess with certain things guidance, right?
But can't you add the code it built into your prompt and just say adjust this code to do this?
That's literally what I did, and yet it decided to rewrite it.
Wow.
Yeah.
So is Lovable now just likable because it didn't do the problem for you?
It's the ex-girlfriend.
Yeah.
On that note.
Yeah. On that note, I'm Kyle Myers.
I'm Rob Katz.
And I'm Mario De Benedetto.
What? You're not still Mario De Benedetto?
I was going to end this.
Okay.
I still am.
And this has been the AI Riff.
Wires hum like whispers in the deep dark night. Shadows dancing strange under neon light. Digits spinning fast like a gambler's hand. The clock chimes change, it's the new command. Oh, the future calls with a voice so clear. A melody of progress in every ear. No turning back, the wheels in motion. A tide of cold like the endless ocean. Binary prophets ride in fading streams. Data flows like rivers fueling all our dreams. Simple or savvy, it's all the same path. Under skies of innovation, we redraw the map. Oh, the future calls with a voice so clear. A melody of progress in every ear. No turning back, the wheels in motion. A tide of cold like the endless ocean. Set the rhythm to the beat of change we sing. Every click and hum a key that rings. A revolution, quiet, but it's vast. Building empires futures cast. Oh, the future calls with a voice so clear, a melody of progress in every ear. No turning back, the wheels in motion, a tide of code like the endless ocean.